The larger objectives is to document the impact of last year's El Nino, the 2015 El Nino, on the glaciers in Peru. And we'll do that by looking at the Quelccaya area, the Quelccaya ice cap, where we've studied now since 1974. And how is that being recorded in the ice? Not only there, but also in Huascaran, which is in the north-central part of Peru. We know southern Peru has a very strong drought associated with these events, whereas northern Peru can actually be wet during the events. So we're looking for maybe a seesaw signal of the event in Peru, and that will help us understand the longer-term archive that we have in the ice cores.
So El Nino really is an atmosphere-ocean coupled system where the sea surface temperatures that we typically experience in the tropical Pacific, they change. So for instance, in a warm event like El Nino, the warm water no longer remains trapped or isolated in the western warm pool region. It actually extends, moves back toward the east into the central and eastern Pacific, and then that impacts also the atmospheric circulation, so trade winds often weaken or even reverse direction. And that coupled system between the sea surface temperatures and the atmosphere change circulation patterns around the world.
So this animation shows a profile of the Andes with the Pacific on the west and the Atlantic and the Amazon forest on the east. And during a normal wet season, there's a lot of moisture traveling from the Atlantic Ocean over the Amazon basin and lifted up all the way to the top of the Andes, where you have snow precipitations that carry all the species and the chemicals that we're going to analyze in the snow. During a normal wet season, lake level on the Altiplano are at normal level. The snow accumulation is usually a lot on Quelccaya, between 2 and 3 meters of accumulation. On the Pacific side, there is the normal upwelling of cold water coming from the bottom of the ocean and rising up to the surface, bringing a lot of nutrients. But that does not influence Quelccaya so much during a normal wet season, because most of the influence is on the Atlantic side. During an El Nino, the Pacific Ocean is warmer, and you don't have this cold current that brings all the nutrients, but the moisture is carried also from the Pacific all the way to the top of the Andes. You still have some influence from the Atlantic, but it's somehow balanced with the Pacific influence. Wet season is drier during an El Nino, so you could expect more biomass burning, forest fires in the Amazon basin, for example. But also on the Andes, there's not so much vegetation, but it is very dry, and the dust of the surrounding desert is picked up by the wind and covers the ice cap much more than usual. The annual accumulation is much smaller than a normal wet season. We expect to see more black carbon due to the more vigorous fires going on in the Amazon. The lake level and the Altiplano is lower, so that means that more of the land surrounding the lakes are exposed to the wind, and that is also a source of dust.
So one of the main areas that we look at in terms of impacts are in the equatorial region of South America. So if we think about Peru, often during El Nino, or the warm episode during December through February, It's often wet in northern Peru, but there are teleconnections around the world. For instance, if you think about the Midwestern United States, often during El Nino winters, it's really dry. If you think about the southern hemisphere, if we're looking at, say, off the west coast of Antarctica, we often see these large, what we call blocking highs, or areas where storms get deterred around these highs into southern South America. So we see often wetter conditions in, say, central Chile. Those are some of the typical impacts we see around the world.
This was my 42nd year of coming to examine the Quelccaya ice cap, starting back in 1974. And the thing is that with repeated visits, you actually get to see the change taking place. And now it turns out that Quelccaya is the oldest documented tropical glacier on Earth, and the changes have been really dramatic, and they are accelerating. This year, I've never seen the surface of the ice cap in as bad a shape as it was. But I think the combination of a warming Earth and this very large El Nino of 2015, which brought drought to much of Peru, contributed to the very large changes that we've seen since last year on this ice cap.
In addition to the work with the isotopes, the oxygen isotopes and the dust, and looking at how El Nino has affected the snowpack over the years, we are also analyzing the snow for the major ions, and each of these have a specific source, or sometimes several sources, and so we will compare the concentration of those ions from the snow pit of last year with the snow pit of this year, and we will also identify in details the chemical signature of El Niño. We do that by analyzing each sample by ion chromatography. So the samples are melted and they represent a layer, a subseasonal layer. So they are melted and we bring them to the clean room and we pour each of them into very clean vials and we analyze them within a day. We can analyze 60 samples, for example.
One of the questions that these observations raise is there a threshold that we are passing where these El Niños have a greater and greater impact on the archive of ice in the Andes. But what we are trying to do is to take the major El Niños that have occurred in the last 43 years of record and determine what is the marker for an El Niño. Enriched isotopes, reduced accumulation, and then take the records that we have from the deep cores and reconstruct a El Niño, an ice core index for past El Niños. We've been working as a team on what we collected in June and July from these pits and shallow cores. So we have two 10-meter cores from Quelccaya, from the summit, from the North Dome, and we have a 10-meter core from the Col of Huascaran, which is about 390 meters higher in the atmosphere than Quelccaya. The cores themselves have a very interesting record that shows that during this year for Quelccaya, the isotopes were enriched by 5 parts per mil above the average for the last 43 years. And the net balance, the amount of snowfall on the glacier, was 64% less than the mean. So the combination of the warmer temperatures and the low accumulation had a dramatic impact on the ice cap itself. So we, after getting the cores out of Quelccaya, we went to Huascaran, this higher elevation site, and that core was amazing in many ways in that it shows that the record is still being preserved there. We have the same annual oscillations in isotopes that we had back in 1993 when we drilled an ice core to bedrock. And so the record is still being preserved at this northern higher elevation site. And, but there too, the isotopes enriched, not as much as they did on Quelccaya, but about 4 parts per mil. And the net balance was about 29% below average. So, but it turns out that the 2015-2016 El Niño had a much different impact on Peru than the normally what we see in the Andes, as it also had in places like California. The precipitation, the high precipitation that usually comes with those El Niños didn't come in 2015-2016. And likewise in the Andes, the northern part of the Andes didn't get wet like it normally does, but the south was dry, but even drier. But the whole Andes suffered from a drought. We have a fantastic record from Huascaran from drilling there in 1993. However, it is the only glacier, the closest glacier to the equator, where we have not only the recent past, but we have ice deposited during the last ice age in the tropics at 9 degrees south of the equator, right above the Amazon basin.
All that previous core, all the glacial stage ice has been analyzed in not only our lab, but labs around the world. But for at least the near term, we need to get that archive and preserve it for the future, not only for what we could measure now that we couldn't measure in 1993, but to what might be measured 20 or 30 years from now that we haven't even thought about. So it's the archive that's really at risk, and Quelccaya kind of demonstrates this, because when we drilled it, the deep cores back in 1983 and then again in 2003, we could see how the record is now being compromised through the melting. Surface melting started there in 1991, and in 2016, this is the worst melting that we have seen, and the record is almost completely lost, the annual oscillations in the isotopes. That will occur on Huascarán. It's just a matter of time, because as the world warms, the zero isotherm is rising throughout the tropics, and it's now, at least seasonally, above the summit of the Quelccaya ice cap, and eventually it will be up above the col on Huascarán. So it's important to capture that record while it's still unaltered.